Welcome to our new lecture of signals and systems. In the last lecture, we learned about what is a signal. It is a mathematical representation of a physical quantity. In this lecture, we are going to learn about two basic types of signals, continuous time signal and discrete time signal. So, what is a continuous time signal? It is a signal which exists for every point in time within specified intervals, and mathematically it is represented by xt. So one thing to be noted is that the use of this kind of brackets, and this is just a kind of notation to represent a continuous time signal. Here as stated above, xt is a kind of signal which varies continuously between a specified time interval. Let our time interval be minus t1 and t1. So our xt varies between minus t1 and t1 continuously. It means for every minute and small interval of time t, there is a range of values of xt which is continuous. It means there is no value between minus t1 and t1 between which xt doesn't exist. Another point is that xt is continuous both in amplitude and time. So it should be noted that, as we said now, that there is no point between minus t1 and t1 where xt doesn't exist. So both our time domain and our x-axis and our y-axis both are continuous. Now let's see what is a discrete time signal. A discrete time signal is a kind of signal which is defined and exists only at specific instants of time, usually separated by equal intervals. It will be more clear from a diagram, and mathematically it is represented by xn, where the use of square brackets and the variable n are just a way of representation. But the main difference is that here, like we said, time t is a continuous variable that varies continuously between minus t1 to t1. Here n takes a discrete set of values and it is not continuous. So it will be more clear graphically how xt looks. So here it is our x-axis and it is our y-axis xn. Here for different set of values of n, there are different values of xn. Suppose this is for n equal to 1, n equal to 2, n equal to 3, n equal to 4, n equal to 5, n equal to 6, 7. And it can be seen that suppose between two values, suppose n equal to 2 and n equal to 3, n equal to 2 and n equal to 3, there is no value of xn exists. So from here it can be seen that xn is not continuous between n equal to 2 and n equal to 3. So this is our discrete time signal. Now let's see what are the applications of this continuous time signal and discrete time signal in the real world. Now the next question that comes to our mind, which is most commonly used, the continuous time signal or the discrete time signal? So it will be more clear after we know the applications of the continuous time signal and discrete time signal. So, the continuous time signals are actually used in representing real world phenomena. Like we discussed, if you remember in our last lecture about the voltage signal, the speed signal, so these are real world physical signals. The continuous time signals are used to represent directly the temperature signal, pressure signal, continuous video signal, kind of signals where the value there are variations continuously in the time domain. Okay, and this type of signals, if we convert to discrete time, then the valuable information that exists that needs in the processing will be lost if we will convert this real world signal for some analog system to the discrete time signal. On the other hand, discrete time signals are used in as an input to digital systems where they can be manipulated easily using algorithms, where there are efficient processing, where they can be stored easily, transmitted easily. Also, discrete time signals are robust against noise and interference as compared to the continuous time signal. So, here we can see that both continuous time signal and discrete time signal have different importance. In terms of accuracy, if we don't want lost our information for a set of values of time, means in kind of systems or applications where accuracy is more important, the continuous time signals are used, and the kind of systems and application where efficiency is more important and the noise and interference we have to keep in mind, then their discrete time signals are used. So we can say which is more important or most commonly used. It depends upon the application and the requirement of the system. Also, it's not that we cannot convert the continuous time signal into discrete or discrete to continuous. We can always convert a continuous time signal to a discrete time signal using continuous time signal and discrete time signal using a method called sampling that we are going to learn in our coming lectures, and also convert the discrete time signal back to continuous time signal using a technique called reconstruction that also we are going to learn in our coming lecture.